So welcome back. So as discussed in the previous session, so we are going to write two programs here, one for the fixed window, one for the variable window. So for the fixed window, we are going to solve the problem that we have discussed in that video, maximum sum subarray of size k. Okay, so hope you are knowing this problem because we already have discussed in the previous lecture. So let me create one class for this, max sum subarray, okay, and k size, so that it will be clear by the name. In this I'm going to create one static method. So public static int, and I'm going to calculate the max sum, and input is of type int, right? So that will be nums and one window size, so that will be int k. Okay, typo. All right, now so there are one edge cases that you have to think of. So there are two cases when nums is not having any value, or it is having the value but size is less than the k. In both the cases we can't do anything, right? So I'm going to check if nums equal to null or nums dot length that is less than the k. In both cases I'm going to return -1 because we can't do anything. There is no result for that, right? Now coming to the actual implementation. So there are two kind of sum. One is the sum at the window level, and one is the max sum at the whole input level, right? So let me create one window sum. I'm initializing this with 0, and now I'm going to first calculate the k size of subarray sum, because I have to initialize from there, right? So for int I equal to 0, I is less than k and I plus plus. For this I'm going to just do a simple operation, that is window sum equal to nums I. So window sum equal to window sum plus num I, right? So this is kind of, let me write here also, it's a initialization, right? Now I have calculate my step first. The first window sum I have found. Now I'm going to transfer because this is my first window, so that will be the same as the for the max window also, right? So I'm going to declare one variable here. So the variable name is int max sum, that is going to be initialized with the window sum. Okay, now I'm going to use the logic of maximum subarray problem, where for each input next element I am going to add that element in the window, and at the same moment I am going to remove the previous element. Okay, so for int right, that is equal to k, I am going to start from k, right? K, and right should be less than nums dot length. Hope this is okay. And of course the right minus I have to do. Okay, so in this case, I mean right minus no, right plus, sorry, I thought I'm doing some different operation. Okay, so right plus I have done. Now I have to add the current element in the window sum. Okay, so window sum equal to window sum plus nums right. In the same moment I have to remove the previous element, right? You have to remove the element going out of the window, because window size is fixed. That's why you are making it sliding. So what I have to do, so since already we have taken the k size, so after each k the counter is going to be start again with the k plus 0, k plus 1, k plus 2. Okay, so what I have to do to find the previous or the first element of the current window is nothing but the current position minus k. Okay, so window sum equal to window sum minus that will be nums and right minus k, correct? So whatever value is coming, whatever value sum is coming, you have to compare. Now the max sum is here and this sum, which one is greater? Okay, so max sum equal to math dot max maths dot max is not coming, yeah, coming. So max sum comma window sum. So this is the logic for finding out the max element. So what I have done, I have initialized one window sum, one local variable you can say, and for each initial k value I am going to initialize this window with that sum of the first k element. Once we got it, now what I have to do, after that I have to move the current window by 1 and have to remove the previous element to keep the window size constant, right? So I am adding the current element, then removing the previous element to keep the size constant of the window, and then I am trying to find out the max of both sum, earlier max sum and current max sum, right? A current window sum. So whatever it is there, this is going to return the answer, return max sum, right? So this is the whole code for this. So hope nothing much complex in this. The only complex was to understanding the window, how the window, if we're able to visualize the window sliding movement, so you can easily find out this solution, right? So now we are going to solve the same logic with variable. Okay, so if you remember in the previous discussion, we are talking about the longest substring without repeating character. So we have to keep on increasing the window until we are getting the repeating character. Once we got the repeating character, then we are going to find out what is the maximum length at that particular moment. I will store somewhere. Then again we do the operation unless until we are reaching the end of this given string. Okay, so let's see the program. So probably you will be understanding more. Okay, so let me create one class. So that is longest substring without repeating. Sorry for this big name, but I'm writing the class name in such a way that you can understand what the problem it is we are solving. Okay, repeating. Okay, let me rename it. Right click, go refactor and rename it. Okay, so what I'm going to do in this, I'm going to create one, of course, the static method. I have to find out the length of longest substring. This is our goal, right? I'm writing the method name, length of longest substring, right? And this method is going to take input of the one string, that is yes. So I got one string s, and I'm going to calculate the characters count until the repeating character. So what we are going to do in this, so to find the duplicate, we must have stored all the previous element in somewhere, so that when the current element is coming, so that we can compare with the previous set of or visited elements and characters and find out if this character is already existing. It means this is a repeating character, and then we can change our decision. Okay, so somewhere I required one storage which is store this characters whenever visiting any character. Okay, so that I'm going to take set because duplicacy is involved. So set character, set of character that I'm going to give a name set that equal to new hash set. Okay, new hash set. Okay, so let me import this. Okay, now of course I'm going to start with the left one variable that is going to point the start character, and one I need a max length to find out the same way like previous example. This is going to give me the actual length of the string without any non-repeating character. Okay, so okay, let me start. Okay, before that let me define this max length, and that is equal to 0. Now going to start the for loop. In the for loop, what I'm going to do, I'm going to start with the right character, int right equal to 0, which is going to start from the current element, and I have to do this operation until right is less than s dot length, right? I have to move until the last element, and then I have to do the right plus plus. It's a very simple. So now in this loop, what I'm going to do, first I have to check if the right character that I'm going to read is already present in set or not. Okay, first thing. So let's do that. While set dot contains nums contains s dot char add. So char add right is the 0 index, whatever element is there. If set is having this character, it means that is already visited. It means this character is a duplicate one. So what I have to do in the case of duplicate, I have to remove this set dot remove. I have to remove this character actually. Okay, so I'm going to remove this character from the not the right one, actually I have to remove the left one, right? Because we are shrinking, so this is called shrinking. We are shrinking, so shrinking is happen always from start, and then left will move to the next character. Okay, so this code is doing nothing but this code is simply, if any duplicate character is coming, it's going to remove that character from the set and push the position towards the next in the with the left pointer. Okay, if this condition is false, it means it's a very fresh character, it's not visited, it's coming for the first time. So simply I'm going to add in the set. Okay, this is added. Now here I have to calculate the max length. So the max length equal to math.max of the current length and max length. So max length comma math.max. What I have to find out max length first, and then I have to find out the current length. The current length is nothing but current position minus previous left position. Okay, and plus 1. Hope this makes sense. So now in every for loop, I'm going to check two conditions. One condition is checking if that character is already present in the given set. It means that is a duplicate one. So simply I'm going to remove from set. And I'm shrinking actually window. I'm shrinking, and let plus nothing but it's reducing one size from the left, right? If this condition is not true, then simply I'm going to do the simple operation. I'm going to add that character in the set and now calculating the max length in that case. Okay. right? Okay, so once this loop is done, then whatever result is in the max length, I'm going to return that, right? So this is the code, simple code that we have written, and this is the main core logic of this particular problem, where you have to find out the longest substring without repeating character. And this is the case of variable window. So we have solved this. It's a very sample. So remember two things now. For fixed window size is constant. We slide it by adding the next element and removing the previous element. But for the variable window expands with the right pointer and shrink with left pointer. Okay, this is shrinking case. Okay, and right pointer is always increased towards the, or right pointer always talk about expansion. All right, so this is all about that particular sample programs. We'll solve more type of problems on this. So let's see you in the next problem. Okay, enjoy.